Let's continue with community member extraordinaire and back-end engineer at Spotify, Mohammed Aboullaite, showing us how to build a fast workflow with Kubernetes and Java. Welcome, Mohammed.
Hello, everyone. I am Mohammed. I work as a backend engineer at Spotify, and also I'm Google Cloud Innovator Champion. And today, I'm going to highlight some great open source projects by Google Cloud team. Thank you for that. That makes working with Java and Kubernetes, especially GK, a lot more fun and speed up our development workflow. So when we talk about developer workflow, and we call it also the inner development workflow, we talk about 4 major steps. The first one is introducing business changes, making new feature, introducing new feature, fixing a bug, or actually just improving the user experience, right? We call that the code phase. And then once we're happy with our changes, we compile the code, we build it in order to generate an artifact. That could be in a traditional Java application, a jar, or whatever Java artifact you have, or you can build actually that container image. Once we build our artifact, we deploy it either to a traditional Java application server, or it can be to the cloud in a Kubernetes or whatever your container orchestration tool. And finally, we do some primitive testing. Now, I'm not talking about integration tests, unit tests. I'm just talking you opening the browser or whatever API tool you want to have, and testing actually your changes. So this is actually the 4 major phases of our development workflow, right? However, when we move it to containers into the cloud, containers are great, right? They become the executables of the cloud, and they change the way we develop, architect, and deploy our containers. They have a lot of goodness. We heard for the past 10 years a lot of goodness about containers, a lot of companies breaching how awesome they are, right? However, when it comes to development, they didn't make actually the development experience fun. They bring this additional layer of abstraction that made the developer experience a little bit slow. Now, let's take this example. Those are the steps that a typical developer will follow in order to deploy his changes. Like we start with building our Java artifact, then building our image using Docker build command, right? Then we tag that, push it. God, I'm not even halfway through, I'm tired. And then we change our manifest, deploy it using kubectl apply. We connect to our cluster, check if the pods are healthy, checking the logs, and finally, testing our changes. I made it. So if we want to decompose and categorize those all steps, we can categorize them into 5 major categories, actually. The first one is the build. So we build our artifact and generate our container, jar, whatever, and then we containerize it. Sorry. Here, in the containerized phase, we generate our container image. And then we push it to our remote registry. And then we deploy it in our favorite container orchestration tool. And then we connect to that cluster to check if everything is working, right? However, we as developers, we don't care about all the steps, right? We only care about introducing changes, making changes, and checking that the code we wrote works according to expectation. It does the job that we needed to do. And in 2014, a dear friend, which is James Ward, which is a Kotlin PM, wrote that long development and validation cycles really sucks. So when a developer spends a lot of time waiting for the changes, waiting to see and test their changes, actually, their productivity will eventually plunge, and it will affect the business. Because a slow developer means that the whole team will be slow to deliver a feature, and it will also mean that the other teams that depend on your team will actually get slow. So the whole business becomes to get slower, losing billions of dollars just of a broken developer experience, if I might say. So this has nothing to do with my presentation. I'm just trying to look smart in front of a smart audience. But that's only to say that we need to analyze the 5 steps and try if we can automate them, optimize them in order to make the developer experience working with containers, and in this case, Java. And some of the tools apply to other languages, but I'll be focusing on Java in this case. And analyzing the 2 first steps, which is the build and containerize, there are some issues and some things that we can improve regarding the way we build our containers images, right? Starting with the builds take longer when we build our artifacts in containers compared to when we build them locally with our favorite build tools like Maven or Gradle, right? Whatever we do, whatever we optimize, the build in containers take longer compared to building our Java artifact directly. With the rise of cloud native and the move to fat jars by all the Java frameworks, Spring Boot, Micronaut, Quarkus, we started building the fat jars. Now, fat jars are great if you're running them directly. However, they break the caching optimizations of Docker and containers in general, since each time you change a tiny little bit of your code, you are building a new fat jar, and that means a new hash ID of your image layer, and that needs a slow push process and slow pull and deploy process as well. There are some limitations with the Docker build comment, like sequential execution. It cannot execute comments in parallel. There are some caching issues, and especially if you are mounting folders, it pollutes your current file system with root files. No caching issues for security reasons, obviously, and no volume, sorry. And finally, there are no safe way to accessing private repositories such as Git or S3. Now, to be completely transparent here, those issues some of them are solved with BuildKit. So if you are not using BuildKit yet, try to enable it in your Docker desktop. And finally, Docker CLI is great. It has a lot of options to enable you to do magic things. However, it's become overloaded over the year with more features that aren't necessarily developer-focused. It has features for Docker Swarm. Who is using Docker Swarm? Whatever. And a couple of years back, it has like some features for Docker EE, right? So it's maybe not the right tool for the job. And we, as Java developers, are familiar with the standardized artifact. Like, we are familiar with building our code and generating a jar, a var, an error, whatever. And the ideal scenario for us would be to use the same old build tools, Maven and Gradle, and generate the new unit of deployment of the cloud, which is containers. And thanks to the Google Cloud engineers, we have such a tool. It's called Google Jet, and it stands for Java Image Builder. So Java Image Builder is actually a pure Java plugin. So if you want to improve something, fix something, you can actually just contribute to the code. It's open source. It uses both Maven and Gradle. And my favorite part is actually it's daemonless, meaning that you don't need to have a Docker, this daemon installed on your machine. And it is fast, especially under reproducible builds, and it's reproducible. And what Jib does is basically similar to what's in this Docker file. So Jib, since it's a Java plugin, it splits your application into multiple layers. So it benefits from the caching mechanism of containers. And you put the files that are less likely to change on the top, which are your dependencies, your resources, and the files that are more likely to change on the bottom, which are our class files. And that helps if you change it only the class files, only one layer will get changed rather than the whole application, basically. So that's why the reason why it's fast, especially in the reproducible builds. And Jib is really customizable, really configurable. You can configure anything you want. Your base image, I forgot to mention that it generates OCI-compatible format, so that's why you don't need to have a Docker daemon. It has 3 major phases, or 3 major goals. The first one is Jib build, or Maven Jib build if you want to. It basically builds an image and push it to a remote registry. If you want to cache your image locally in your Docker daemon, you can use Docker build. And if you would generate a tar file, then you can do that with build tar. And the default base image in Jib, it uses Distro Java. And Distro Java is a part of a cool Google Cloud project as well, called it Distroless Container Images. Now, Distroless Container Images aims to create container images that contains only your application and its runtime dependencies, restricting what's inside your application or your container to exactly what your application needs to perform its function. Now, that is great for two reasons. From a security point of view, since you have only what you need during runtime, and from a size point of view, which means that you will have faster push and you will have faster pull and deploy as well. And so with Jib, we hopefully managed to reduce the build and containerize time. How about deployment time? Can we automate the other steps, which is like tagging our images, pushing it, and deploying it to our cluster? And another cool open source project from the Google Cloud engineers called Scaffold. Super easy. It's basically a command line tool. It's a command CLI that does a lot of things. It automates the build of your container, pushing it, deploying it, and then tailing the logs, and even does port forwarding if you want to have that. Now you can use Scaffold on the favorite CI tool and shove it into your favorite CI tool to have a consistent experience between the development and CI/CD, but we are going to focus on the development part in this talk. So this is what Scaffold basically does. It does a lot of things. It syncs the files. It builds the container image for you. It tags different tagging strategies. It tests it. And here you can either use another cool project, open source container structure tests that enable you to test the structure of your container image and verify its compliance. Or you can define your custom text, similar to what we do with Maven tests or Gradual tests or whatever. And it enables you to tag your artifacts and then generate the manifests. So if you are using Customize or Helm, it helps to generate the final manifests before deploying them. And then once you deployed, it tails the logs and gather them, giving you a great overview of how your application is doing so you can have a quick feedback loop. And with that, I'm going to demo some of Scaffold and Jib features. So before going here, I have first a very small Spring Boot application that is basically have one endpoint, which is a hello application that whenever, is it visible in the back? Cool. So it's basically one endpoint that prints an event stream, so each 1 second, and it says hello words. So I have Scaffold already configured, and I have the configuration file here. So as everything in cloud native world, it's a YAML file. You need to live with it. And I defined multiple steps. So the first one is the build step, and I'm basically using Jib. And as you can see in my POM file, I have the Jib plugin already here, the latest version, I hope. And then for the test, I'm using the structured tests. So as I mentioned, you can use the structured test, which is another cool project from the Google Cloud team. And it's basically verify the structure and the compliance of your application. So here, I'm verifying the Java version of my container. That is Java 17, the user ID. And I'm checking that the layers, the files that Jib creates are there already. So quick win. I'm also doing some port forwarding from 8080, the default port of Spring Boot, to port 900. I'm deploying using kubectl. And if I want to start Scaffold, I only have to, in development mode, I have to do Scaffold dev. And what it basically does, it will start to get, if I have the image locally, it will start to pull it up. Otherwise, it will build a new one, push it to the container image, and deploy it using kubectl, as I've mentioned it here. And it will try to pull the logs and deploy the application. Now, this is taking more time than expected, but it's getting there. So it's running the tests, and the tests are failing. Aha. Why do you need to do the Docker daemon? Gosh, this is not good. Do I need to log in? OK, open Docker. Docker trying to kill my demo. Thanks, Docker. Let's try now. OK, just run in. Yes, all passed. Perfect, fantastic. Now I'm trying to deploy my image. Deployment is already done. And you can see here, it's already port forwarded to port 9000. And if I'm lucky, you can see the Hello World application up and running, right? And now what happens if I want to introduce some changes? And so let's say I want to Google Cloud Next. The moment I would next. The moment I hit Control Save, you would see here that it will redo the same process without me doing anything. It will try to build a new image, run the test to make sure that everything is fine, and then deploy it. And when port forward, and then I will see my application in the logs that my application is started. Now, if I go back and refresh, I would get the Google Cloud Nest application up and running. And once I hit Control-C to exit my scaffold dev mode, you will see that the application, it will basically try to clean up your remote cluster, removing all Kubernetes objects there. Now, this is a very simple application, and you may say that, yeah, our production applications are more complex than that. So I still have another production similar application, which is a pit store. So it's using actually Micronaut, and they have it deployed in GKE cluster already. So it has a microservice application with a couple of databases. So it has multiple applications, a front-end application using React, and it's all automated using Scaffold. So I have the front-end application using React, using the sync file. I'm going to demo that in a minute. And I have other applications that are using Micronaut framework, both written in Groovy and Java and different other Java languages. So I cheated a little bit. So my application is already up and running. And if I am lucky, I would see that the application is up. Yes, so this is my application. And I mentioned the syncing feature of Scaffold, right? So I have the Home.js application, which is the front end or the home page of my custom application. What happens if I change it a bit? Next. Now, the moment I hit Control Save, I no longer need to build an application. Since it's a React application, it basically sync the files directly to my remote cluster without building the image, as it's mentioned. Sorry, not this one. Probably it's this one. Yes, sync in my application. So if I go back to my application, since I'm activating the hot reload mode in my React application, it instantly picked actually my application without needing me to do anything. So this was a quick demo of Scaffold goodness. So we managed to shorten the steps from 5 to 1, maybe, or 2. You need to do some configuration with JEP if you're a Java developer, and basically running Scaffold dev in your application to have a decent and a more enjoyable developer experience. Now, talking about the YAML files, and I already touched upon this during the demo. YAML files, I have a problem with YAMLs, but I'm not going to start that discussion now. But YAML files, especially if you're working in the cloud-native world, are really, we end up managing a lot of YAML files per environment, per version. It adds a lot of complexity. So we need a way to customize it, and you're probably already doing that. And either we have basically a couple of options. Either we start using Helm, and Helm follows a configuration over values kind of solution. So you have basically the base or the configuration. You define variables in your Kubernetes manifest, and you define the values of those variables depending on the version and also the environment that you want to run your application into. Helm 3 solved a lot of problems and a lot of pains with Helm, since it becomes now a client-focused version. Previously, it was a client server, and you need to have Taller, or whatever it's called, on your Kubernetes cluster. Now it's much more lightweight, and it does all its magic in the client side. And my favorite tool is actually Customize. So Customize, as the name suggests, is basically a solution to customize your application. And it follows a different approach. It's basically enable you to define a skeleton, which is the shared manifest of all your versions and all your environments. And we define additional YAMLs per environment or per version, right? And what it does is basically what's in this slide. So we define our skeleton, our base image, or base configuration file, and we define the changes and updates that we want to do. And the generated version will be basically the merge of those two. And we end up with a much structured YAML file that enable us to basically define and deploy your application per version and per environment. So this is basically it. Scaffold is a great tool that be customizable and extendable with different environments. For building, you could use Jib, you could use Docker build, you could use build packs, whatever you want. There are different testing strategies, different tagging strategies, and different way to deploy your applications. And if you want, you can make your own and build your own as well and shove it into Scaffold. So with that, I want to thank you. And the demo of today is already on GitHub, open source. And if you have any question, be happy to take them.